This is part 1 of a review of exponential and logarithmic functions. This is AP Pre-Calculus topic 2.9 through 2.15. If you appreciate this content, please give it a like.
Number 1. The logarithmic function L is given by L of x is equal to -3 log base 4 of x. Which of the following pairs of statements correctly describes the end behavior of L? Hopefully you have memorized that the parent function log base 4 of x looks like this. The 3 in the front, ignoring the negative sign for a moment, is a vertical dilation by a factor of 3. Stretching this vertically does not change the basic look of the graph. However, the negative sign in the front is a reflection over the x-axis. So y equals -3 log base 4 of x will look like this. The limit as x approaches 0 from the right is positive infinity. As we approach the y-axis, the function rises. So let's see. It looks like the answer is going to be B, because this is the only one that says the limit as x approaches 0 from the right is positive infinity. Let's check the right end behavior. The limit as x approaches positive infinity is negative infinity. As we go towards the right, the value of the function falls. And that is what this says. Notice that because of the vertical asymptote at x equals 0, for the left end behavior, we had to talk about the limit as x approaches 0 from the right, not the usual limit as x approaches negative infinity. This graph does not go towards negative infinity. So we knew immediately that options C and D were out. Number 2, let h of x equal 2 times the natural log of x minus 3 minus 5. Which of the following gives the domain of the function h? We have memorized that the parent function natural log x looks like this. We just have to do 3 transformations. The 2 in the front is a vertical dilation by a factor of 2. A vertical stretch on this graph does not change the overall look of the graph, so we can ignore that. The -5 on the end is a vertical translation by -5. Shifting this graph vertically also does not really change the look of the graph. We have this vertical asymptote at x equals 0. But moving the graph up or down does not move that asymptote. So the only transformation we really have to worry about is the x minus 3, which is a horizontal translation to the right by 3. The graph of h of x would look something like this. The domain is the x values, which go from 3 to infinity. So the answer is C. Number 3, the logarithmic function p is defined by p of x equals 1/2 log x. Which of the following statements about p is correct? We have memorized that the parent function log x looks like this. A vertical dilation by a factor of 1/2 does not change the look of a graph like this. So p of x looks like this, which is increasing from left to right and concave down. So the answer is B. Number 4, values of function k are shown in the table above at selected values of x. Determine if function k could be linear, exponential, or logarithmic. Explain your reasoning. If k of x is linear, the rate of change will be constant. These are the changes in the input values, and these are the changes in the output values. We find the average rate of change on each interval by dividing the output value change by the input value change. We notice that the rates of change are not constant, so k of x is not linear. If k of x is exponential, the output values will vary multiplicatively, or you could say proportionally, on equal length input value intervals. We do not have equal length input value intervals, so this is not looking good for exponential. However, if k of x is logarithmic, the input values will vary multiplicatively on equal length output value intervals. And that is exactly what we see. The input values vary multiplicatively for equal length output value intervals. K of x could be logarithmic because the input values vary multiplicatively, or you could say proportionally, for equal length output value intervals. Number 5. The logarithmic function f is defined by f of x equals 2 natural log x. Which of the following pairs of statements correctly describes the end behavior of f? We have memorized that the parent function y equals natural log x looks like this. A vertical dilation by a factor of 2 will not change the look of this graph. So what's the end behavior? On the left, x is approaching 0 from the right. So we've narrowed it down to either a or b. And as x approaches 0 from the right, the value of the function is falling. In other words, the limit as x approaches 0 from the right is negative infinity. So that means the answer is going to be A. But let's follow through and look at the right end behavior. As x approaches positive infinity, the value of the function increases. In other words, the limit is positive infinity, which is what we see here. Number 6. The function f is defined by f of x equals negative 1/3 log x. Which of the following pairs of statements correctly describes the end behavior of f? We have memorized that the parent function log x looks like this. What about negative 1/3 log x? The 1/3 is a vertical dilation by a factor of 1/3. That's not going to change the look of the graph. However, the negative sign is a reflection over the x-axis. So this graph is going to look like this. So how about that end behavior? The left end behavior is the limit as x approaches 0 from the right. So that narrows it down to either a or b. And as x approaches 0 from the right, the function is rising. The limit is positive infinity. So that means the answer is going to be B. On the right, as x approaches positive infinity, the function falls. The limit is negative infinity. And that is what we see. Number 7. The logarithmic function f is defined by f of x equals negative 5 natural log x. Which of the following statements about f is correct? We've memorized that the parent function natural log x looks like this. The vertical dilation by a factor of 5 does not change the look of the graph, but the negative sign is a reflection over the x-axis. This graph is clearly decreasing from left to right. So we've narrowed it down to either C or D. Now, how about the increasing rate versus decreasing rate? That depends on the concavity. When a graph is concave up, it is an increasing rate. If the graph is concave down, the rate is decreasing. This graph is concave up. So the function is decreasing, but at an increasing rate. So the answer is C. Number 8. The logarithmic function g is defined by g of x equals 3 log base 5 of x. Which of the following statements about g is correct? The parent function log base 5 of x looks like this. A vertical dilation by a factor of 3 does not affect the look of this graph. So, this graph is clearly increasing from left to right, and because the graph is concave down, that's a decreasing rate. So it is increasing at a decreasing rate, and the answer is B. Number 9. What is the inverse of the function g given by g of x equals 4 log base 2 of x plus 3 minus 1? So to find the inverse, you switch x and y and then solve for y. So let's put x out here in the front. X equals 4 log base 2 of y plus 3 minus 1. Once we have solved for y, that will be the inverse function. Let's start by adding 1 to both sides of the equation. So we get x plus 1 is equal to 4 log base 2 of y plus 3. Now we divide both sides by 4. That's going to give us x plus 1 over 4 is equal to the log base 2 of y plus 3. We can make the log base 2 go away by dropping a base 2 on both sides of this equation. That means the x plus 1 over 4 is now the exponent of this 2, and all of this is the exponent of this 2. But the base 2 and the log base 2 cancel each other out. So on the next step, we will have 2 to the x plus 1 over 4, and all of that is the exponent of this 2, is equal to, and the base 2 and the log base 2 cancel out, which leaves us with y plus 3. Finally, we will subtract 3 from both sides. And for the final answer, instead of writing y, we need to write g inverse, which looks like this. So g with a little -1 superscript. So that's read g inverse is equal to 2 to the x plus 1 over 4 power, and then minus 3. Number 10. Which of the following expressions is equivalent to natural log of 2x to the third power over the square root of y, where x and y are positive constants? Quick side lesson. If you have the log of an expression involving multiplication or division, you can expand this into the sum or difference of logs with a term for each factor. The factors that come from the numerator lead to positive terms, so I will have a positive natural log a and a positive natural log b. The factors in the denominator will lead to negative terms, so we will have minus natural log c and minus natural log d. This log expression has 3 factors inside, so I can expand this into the sum or difference of 3 logs. Because the 2 is in the numerator, I will start with a positive natural log 2. The x to the third power also in the numerator will give me a positive term, so positive natural log x to the third power. But then the square root of y in the denominator will lead to a negative term, so negative natural log square root of y. We know a property of logarithms that says if you have the natural log of something with an exponent, you can move that exponent to the front of that term. So I will have my natural log of 2, but I could write this as plus 3 natural log x. And then the square root of y is the same thing as y to the 1/2 power. And we can move that 1/2 to the front and write minus 1/2 natural log y. This is a perfect match for option B. Number 11. Selected values of the function h are shown in the table above. Which of the following claim and explanation statements best fits these data? We have learned that if the output values are proportional, meaning they change multiplicatively for equal length input value intervals, that means the function is exponential. On the other hand, if those concepts are reversed, and the input values change proportionally for equal length output value intervals, that means the function is logarithmic. And that's what we see. The input values are changing multiplicatively for equal length output value intervals. So h of x is definitely logarithmic. This means we can throw out options C and D, which say exponential. Now, which justification is correct? Option A is talking about equal length input value intervals. That's not what we have. The answer is B. H is best modeled by a logarithmic function because over equal length output value intervals, the inputs are proportional. Number 12. What is the value of the expression log base 2 of 8 minus log base 2 of 10? Well, a log is the exponent that turns the base into this other number. So the log base 2 of 8 is 3 because 2 to the third power is 8. We know there is an invisible 10 when you just see a log without a visible base. So this is really the log base 10 of 10. The value of this is going to be 1 because 10 to the 1 power is 10. So really we have 3 minus 1. So the answer is 2, which is B. Looking at number 13, what exponent turns 9 into a 3? We know that the square root of 9 is 3, and square root is the same thing as 9 to the 1/2 power. So that's the value of this term. Similarly, the square root of 4 is 2. That's the same thing as 4 to the 1/2 power. So we have 1/2 plus 1/2, which is 1. So the answer is C. Number 14. The log of 1 is always 0. That's because the power that turns any constant into a 1 is 0. 5 to the 0 power is 1. Now, what about this? What exponent will turn 6 into 1 over 36? Well, if we ignore the 1 for a quick second, we know that 6 squared is 36. What will make it 1 over 36 though? So 6 squared is 36. If we make that exponent a negative 2, that will cause it to be 1 over 36. Let me follow through on that. 6 to the negative 2 power is the same thing as 1 over 6 squared. A negative exponent drops you down to the denominator, and this does give you 1 over 36. So we have 0 minus negative 2. Be really careful right here. We have 0 minus this expression. That's 0 minus negative 2. Of course, that's really 0 plus 2. So the answer is positive 2, which is D. I have a feeling that several students will accidentally pick A, thinking that it's negative 2. Number 15. Natural log and base E cancel each other out. So this term is just 3. Now, what power will turn 9 into 1/3? Well, the square root of 9 is 3. That's 9 to the 1/2 power. So if this 1 wasn't here, then the answer would be 1/2. However, because the 1 is here, it's really going to be a negative 1/2. Let me separate that out a little bit. Let's follow through on that. I claim that negative 1/2 is the power that will turn 9 into 1/3. So let's check that. What is 9 to the negative 1/2 power? Well, this is the same thing as 1 over 9 to the positive 1/2 power. The negative exponent drops you down. But of course, 9 to the 1/2 power is really the square root of 9. So this is 1/3. So we have 3 plus negative 1/2. So this is 6/2 minus 1/2, which is 5/2. So the answer is B. Number 16. Let L of x equal negative 2 natural log x. Determine the end behavior of L as x increases without bound. Express your answer using the mathematical notation of a limit. We have memorized that the parent function natural log x looks like this. The vertical dilation by a factor of 2 does not change the look of the graph, but the negative is a reflection over the x-axis, so this function will look like this. Now, the end behavior as x increases without bound is the limit as x approaches positive infinity of L of x. I'm going to make this a script so it doesn't look like a 1. As x approaches positive infinity, this function is falling. In other words, the limit is equal to negative infinity. So that's it for number 16. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.